Okay, we will start a new term, electrostatic. That's the book that
Yeah,
you should get.
yeah, the second edition one, yeah, is with me. Sure.
Second semester, fourth edition.
Yeah, after this I'll go buy lah.
Okay, so there are four subtopic: Coulomb's law, electric field, Gauss law,
Okay,
electric
okay,
potential.
all right.
That's your syllabus, right? Basically, it's always important to refer to syllabus, what they want, but your syllabus is not very clear lah, what exactly they want. Right? They just want you to know the formula, and electric field, they want to the meaning of electric field, sketch the pattern for isolated point charge, electric dipole, that means positive and negative charge, uniformly charged surface. Right? So there is a bit blur. Then you wanted to define electric field strength, and then use a formula, and then describe the motion of point charge in a uniform electric field. So that's always refer to your syllabus. Where is the application? Well, electric field, we use it to determine the charge on an electron on an oil drop in Millikan's experiment. Now, you don't need to worry about all this. You just need to know how to apply the electric field, that's all. Or we can use in CRO to accelerate electron and to deflect horizontally and vertically the electron. Right? There's your Millikan's oil drop experiment, where this is your atomizer. It produces a charged oil drop, and then the oil drop into the parallel conducting plate, and then you just change the electric field to stop it there. Then you use a microscope to observe the size of the oil drop and all that. Yeah, that one you don't need to worry so much. You just, as I say, need to know about the electric field. Right? I'm just going into introduction to you, show you where we apply it rather than just teach you how to apply the formula.
Okay.
And then that is where we accelerate the electron. Right? The cathode is usually at a negative potential. And anode is always at a positive potential. So electron emitted by the cathode is accelerated through a potential difference. Right? That's where we use it. Electron gun here. And then there's your anode, there's your cathode. So the electron emitter is accelerated. And these are your deflecting plate. As I say, you don't need to know that much. Right? There's your STPM work. Just to show you where it's used so that you know what you're studying. Right? So here we use electric field to accelerate electron. Right? We accelerate it here, this part. Accelerate it. And then this part is to deflect it either horizontally or here vertically. And the CRO can be used to measure alternating current or direct voltage, observe the waveform, and to measure frequency. As I say, all these are your SPM work. We will study this also, your topic 16, velocity selector, where the charge particle coming in may have different speed. So we select a particular charge with a particular speed for our study. Or this is what you study in your SPM, Geiger-Müller tube, right, where we make a thin wire electrode. Right? There's a reason for that. Why we make it thin, right? Because we want the electric field strength to be very strong there to accelerate charge. So we got a lot of uses for electric field. Okay, let us start with Coulomb's law. Type of charges. Electron, negative charge. Yeah, it exists in electron cloud. That one is your third semester work. Proton and neutron in a nucleus. Proton is positively charged. Neutron is neutral. No charge at all. So in a neutral atom, number of electron equals the number of proton. Then we come to ions. Right? So when the atom loses an electron, or gain an electron, it becomes an ion. So where it loses an electron, it becomes a positive ion, right? Or you call it chemistry cation. Where the atom gains an electron, it becomes a negative ion or an anion. Right? We don't need to know all these terms. We just know it's an ion. Either it's positively charged or negatively charged. Okay. Remember that when we come to electrostatic, we are interested in charge that is not moving, charge that is at rest. So Coulomb's law, right? Usually we will ask you to state Coulomb's law. So you have to memorize it. The force between 2 point charges, the key is point charges, is directly proportional to the product of the charges and inversely.
It is something like chapter 6, right? Remember the F equal to GMM or R
Yes,
square, something
same
like
as
that.
gravitational force. Same as
The way they tell the definition.
Newton's universal law of gravitation. Same. You can just replace the M with the Q as well. The charge there.
To cut the keyword lah.
And then the G with a constant, that's all. So that is how you write
Yeah.
it in mathematical form.
Okay.
And that is your value of constant given in your exam. Right? You need to know where to find your epsilon naught. That's epsilon naught. Right? So usually K is not given, but we will find that K is more useful. Right? It's not given, but you can derive it. Okay, we look at 2 point charges, one capital Q, one small q, and then from Coulomb's law, we can write the equation down. That's the equation, right? Where K is equals to 1 over 4 pi epsilon naught. Epsilon naught, this epsilon naught is called permittivity of free space. Free space means vacuum, right? And there is the value given in your value of constant or data sheet. And this is also given, right? Whichever you prefer to use. The capital Q and small q are your point charges, right? Magnitude of the charge in Coulomb. R is a separation between the charges. Usually we measure in meter. Force is repulsive, is between two positive charge. Right? So this is your point charge, this is your point charge. So separation is R. And then you just draw a line between the center and draw the force. Okay, any comments so far?
Yeah, repulsive force means because
it's a repulsive
both charges
force.
are the same.
Whereas gravitation is attractive force. Anything to ask?
Wait. Force is repulsive, but gravitation is attractive. Or why opposite?
Gravity is different. Gravity is attractive. It's just you have to understand that positive and positive repel each other. That's why you have learned.
Yeah, okay. Yeah, I mean that one okay. Yeah, I mean force repulsive.
Gravity,
yeah,
you just drop an object, it will fall down to the earth. That's why gravity is all about attractive force.
Okay.
Right? When you drop anything, it falls to the earth because the force is attractive. It doesn't fly up.
Okay.
Right? So light charges repulsive force or light charges repel. Okay. Epsilon naught, sometimes we pronounce it as, it's a Greek alphabet. Right? We call it epsilon naught. And let's try to understand why they give this formula. Right? And sometimes you find K is more useful. You may want to use K rather than epsilon naught. So how do we derive the value of K? As a K equals to that value. Then we can put this value inside here, epsilon naught. Okay, this one. So the 36 pi become on top there. Yeah, 36 pi become on top. 10 to the power minus 9 is here. So cancel that, you get 9 times 10 to the power 9. So if you want, you can remember that. If not, go to the formula sheet and use that. More tedious.
Wait, 1 minute. I want to understand it. How did you do the derivation? Okay, K, the formula is 1 over 4 pi epsilon.
Just replace this value here. and then 36 pi become on top. Cancel
Oh,
that.
you mean the equal
Right.
to epsilon lah, cher.
Replace epsilon naught with this value.
Okay. Now I get it.
Okay, any more
Because you
problems?
switch it lah, right? Basically.
Just easier to use this value rather than this value. A lot of calculation we use this value. But this value is not given in your constant sheet.
Oh, you mean like a default lah, cher, in case like you don't want to do the K, the log
If you
lah.
want to use all this calculation like 4 pi times this value.
But do they give mark for that or not, cher? If no means then I go to straight away lah.
Then you have to memorize your K value to memorize.
Okay.
Right? K is usually called a proportionally constant. Right? It's not found in your data sheet or value of constant because it's not that useful lah. Only useful when you use Coulomb's law to simplify your calculation. What does point charges mean? Right? That's your second point in your note, in your book. If you have got the book, you should get your book soon.
Yeah, force between charges.
The forces
So
are
which page, cher?
just the early page, number 2, second point.
Number 2, second part. Oh, force between two charges from an action-reaction pair that obeys Newton's third law of motion.
Number 2 is
The
on
charge,
page 2.
the charge plus Q repels the charge plus small q with a force F towards the right.
Just basically tell you that this charge, capital Q, repel this charge
Follows Newton's third law
with
of
a
motion.
force, and this charge, small q, repel back this charge with a force. So these two forces are equal, and they are opposite. That's what Newton's third law is about. So they are equal and opposite. Right? That's what it means. That charge there repel this charge with a force. That charge, small q, repel that big charge with the same force but opposite direction. That's all. Right? Newton's third law. Right? So usually we will take the left-hand charge as the origin. We are required to draw a graph or as a reference. Right? So that's how the graph will look.
Yeah, go back again. Charge Q repel charge small q with a force F, correct. Charge F repel, yeah, correct also, but in opposite direction. Charge Q is taken as the, but you can take the other Q as the origin also, right?
Yeah. But usually we prefer to use the left-hand one, easier, rather than the right-hand one.
Why, yeah?
Just for convenient, what for when you use negative sign where you can use positive sign?
Oh, okay.
You always choose simple thing. You want positive direction. Try to work with negative direction as little as possible.
All right, okay.
So that's how the graph look
You
like.
can, but the small one also you can take as a positive direction, right? Assuming you take it as a positive,
whichever you prefer.
right?
But it's easier to take the left-hand charge as a origin. It's nothing to
As a
stop you.
positive
You want
also.
to use the right-hand charge also can. You just have to work with negative x-axis as well.
Okay.
Right? That's how the graph look like. Right? The hyperbola, I said that it go faster.
So as separation decreases, force increases. Oh, correct lah.
So for unlike charges, that means positive and negative charge. Right? That's the reason why we have an origin
they
as
attract
the Q.
Okay.
Right? So the same, we can put a negative sign there, right, to show that this is a negative charge there. And the force is attractive. That's why we have negative. Because we choose to the right as positive, to the left becomes negative force. Right?
Negative sign because it's attractive.
If
it's positive sign means it repels.
Yes.
Okay.
What is the meaning of point charge? Same like point mass. What does it mean?
Point charge. Meaning a point charge is
What does point mass mean?
it has a positive charge or negative charge going in a different direction lah. That's the meaning lah.
No, you forgot already. In your gravitational field, we study about point mass. And we study Newton's universal law of gravitation. What does point mass mean? Right? We always compare the size of the point charge with the distance away. Separation. Right? So the separation must be very much greater than the size. Usually size, if like if it's a sphere, then we consider as diameter. It means the separation R is very much greater than the size.
Size G.
Okay, usually it's a diameter if it's a sphere. Okay with that?
But the condition is R must be larger than D. Okay.
R must be far away compared to the size there, to the diameter of the sphere.
Okay.
Right? Unit. So unit, remember, right? Where we usually they won't test you lah, but sometimes you have to give your answer in unit. So they may mark you 1 mark or 2 mark lah. Right? We have say is farad per meter. How do we get this unit?
M-1.
Right? Farad we will study in the next topic under capacitor.
Okay.
So I'm just roughly showing you how we get the formula, how we get the unit. Right? This is the formula we will come to study later on. We got it from this formula. This epsilon naught is the surface area of the parallel plate. There's a separation between the plate D. Just think of it as distance. There's area. There's epsilon naught. Right? Same like R, where you study resistance, this resistivity, that's your length, that's your area. Okay, and we have said that your K is given as 1/4 pi epsilon naught, and that's your meter per farad. Right? F stands for farad, F-A-R-A-D, the magnitude of the capacitance. Right? We're using capacitance, that's the formula. A is the cross-section area of the parallel plate. D is the separation between the plate. And we just subject your epsilon naught. Take the D, small d across, take the A down, that's how we get there. Right? C is measured in farad, D is in meter, area is meter square. Cancel 1 meter, so we still got farad per meter. That's how we get a unit. Okay, so far?
Okay. So 1 minute, we go back again. Okay, you give the value of K there, and then why the R equals to density L over
This one is just to show you. In resistance, we use this formula. In capacitance, we use this formula. That's all. So we'll come to that later on when we study resistance.
You mean more to derivation lah?
You will encounter more and more new symbol, more and new more quantity. So you have to learn to memorize it and use it.
Okay.
So capacitance is the next topic.
Okay.
Right? Alternative. Right? It can be Coulomb square, Newton, meter square. Right? Where we have the force is in Newton, separation is in meter, and then charge in Coulomb. Okay, so these are alternative unit, which I'm just showing you. Right? These are alternative unit. So epsilon naught, we can rewrite from the Coulomb's law. Right? Unit in terms of Coulomb, Q and Q is in Coulomb. R square is in meter square. Force is in Newton. So that's how we get our Coulomb square Newton minus 1, meter minus 2.
Oh, like that. Okay. This is
Okay,
only for the K lah. I don't know.
Uh-huh.
This only for the epsilon lah.
Yes, alternative unit lah, if you don't want to use Farad. Right? Just think of epsilon related to electric field. It allows the electric field to flow through space. So the space got what you call a constant permittivity of free space as well. Allow the electric field to flow through. Okay with that?
Okay.
You don't need to worry about the constant. Usually they will give you. So if the the charges are in an insulating medium, right? Insulating medium, 7 in your note, right? Then you just replace the epsilon naught with epsilon, that's all.
Yep. Okay.
Right? And we call it permittivity of medium. Instead of free space, we call it medium.
Vacuum.
Previously is vacuum or air. Right? Air and
Oh,
vacuum.
now it's now it's
the medium.
permittivity.
Medium have a permittivity of medium. Right?
Meaning
And
je.
then we use it as epsilon R or epsilon naught. Epsilon R is called relative permittivity of the medium. And this is the value that you will find given in value of constant. Right? This is approximate only. No need to memorize it. It will be given you in the exam if it's required. It's a constant.
So no unit.
No unit.
Something like
Yeah, you can
strain
see
lah.
that epsilon got unit, epsilon naught got unit.
Yeah.
Both of them have the same unit. So relative permittivity doesn't have a unit. It's just a number, a value.
ER got, you say ER got unit, EO got unit, right?
Yeah, epsilon naught and epsilon 0 has the same unit.
If they have the same unit means divide makes sense lah. But times means
Then
wouldn't they multiply?
relative permittivity doesn't have a unit.
Okay then.
Yeah, same formula. We are using the same formula. Instead of epsilon naught, we use epsilon. And then epsilon, we just define it as epsilon R over epsilon
So
naught.
only EHO as a unit, ER doesn't have, right? Okay.
It's just a number.
That means ER. Okay, can. Alright. So that means basically like you want to count means then you know already lah. The total E means there is no unit already.
Okay, 10 minutes time we have to change another Zoom.
Okay.
Right? And you need to note that it's always greater than 1. In case you're asked.
Greater than 1. Okay.
And then air and vacuum is the same. 1.
So this epsilon is a different one lah. Before this is a different one, now it's a different one.
Before that is epsilon naught for air or vacuum. Almost the same value.
Okay.
I can refer to your book. Right? That's your homework.
Wait,
Don't do it, I'll force you to do it in class.
Wait,
It's just in your book. After that, you have a checkpoint, 12.1. Just do that. And then focus on STPM.
The term 1, right? Retake, right? Can you tell me like the tip like how to study? I mean like because you need to study SEM 2, do a lot of
You have no choice one. It's just like maths. Physics, you cannot study like chemistry or biology. It's just like maths. If you don't work, you will forget the formula. I don't know how to use the formula because there's so many formula. Then you get frightened. Like me also. I got a poor teacher when I was in Form 6 like you. Form 5, I like you get credit. Form 6, I struggle because the teacher let us copy notes only and doesn't encourage us to buy even past year paper or revision book.
Nothing.
Nothing. Not like you. You are all very smart. Form 5 already train you all to use your reference book, revision note, use past year paper, but I trust my teacher. That's the problem. I trust my teacher.
Teacher, the homework right, checkpoint 12.1 is page 4 to 5, okay. And then there's only two lah, focus STPM 12, page 31, 36, 3, 8, 9, 14, correct, right?
Yeah. Isn't your book? It's just page 31 to 36, 3, 8, 9, 14. That's related to what we
Scared the questions might differ lah, so I'll go buy the new book then. Okay. Wait, you want me to do 3, 8, 9, and 14? Yeah, okay, cool.
Right? This is just the objective one. So to make sure you reinforce what we have learned. Well, you can try
Teacher,
this
just to
question.
be sure, right? Can you see number 14? This one, because here they put Wendy graph generator. Is it the same similar question? The notebook there.
14 is let me just
Structure.
completely different already.
Yeah.
That's
My
right.
one page 36 is structured questions. Your one is objective archer.
Question 14 is that? Yes, question 14.
Question 14, page what, Archer? Tell me again. You got it from?
That's why I give you early, get the right book, don't get the wrong book, then we have different book.
No, I thought like because then the teacher give this already. I almost wanted to buy. I thought I didn't want to waste.
Buy the old edition. Then we will have different. Then we'll disturb the
difficult
teaching.
this one lah.
14 is on page 33.
33.
These are your past year question.
Oh yeah, my question 14 very different. Yeah, okay. I'll go buy the book after this. I saw the book already. They have. Yeah.
Sometimes bookshop try to sell you the old version, trying to get rid of it. So you have to be
No,
careful.
I actually saw the new version already 2 days, 3 days ago. Just wasn't sure.
Okay, you can try this question just to get you use the formula before I give you the answer.
Okay. 1 minute. That means 1 year from now I'll finish the STPM already lah. Just 1 year from now.
Yeah.
Exactly, because they say the paper finish March 30th or 31st. Yeah. Sem 3, then after that no more already.
Yeah, after that you go to university already.
No, I have to wait 3 months and then 2 months for university. Very long lah.
Yeah, take a break, can go and do some work, learn something. Temporary job.
Okay. You want to find distance between them?
Just using the formula, that's all. That formula.
Yes, I'm using the formula 4 pi epsilon r square. Okay. Teacher, MC means they want to cut into C. M is 10 negative 3.
M
right?
is milli. M is milli. You have to change it
milli
to
means
Coulomb. Change to SI unit.
Yeah, I mean
Coulomb. 10 to the power minus 3.
Yeah, 10 to the power minus 3. Okay, where are 8 and then 6. And then times 10 to the power of negative 3 times 10 to the power of negative 3. That's for Q1, Q2. 8 times 6 times that one, all their charges. And then 4 pi epsilon beta r square. Okay, find the distance between them. We don't know. So, but we know the force only. So 3.0 times 10 to the power of 3. Okay.
Okay, we go to a new Zoom. If you what you want, you can take 5 minutes break. If not, you can try some of the question there. Checkpoint 12.1. While we take 5 minutes break. Since our Zoom is almost gone, almost finished.
I'm almost done. So let me tell you the answer first. Is the answer 12?
Yeah. You can put a negative sign there to show it's a repulse.
Oh no, I didn't put the negative sign
But you
there.
don't want to put negative, don't put any negative at all. No, there is attractive
It's
force.
okay, right?
It's okay. If you put negative here, you have to put a negative for the charge there. If not, it will.
Oh no,
You won't get
because I remember then my teacher there, he never put negative charge or anything. He said don't put.
You just want magnitude only, but not the direction. That's all.
Unless they ask direction, then you put lah. Okay.
So if you can,
I got the answer 12.
So you can capture this one. I can capture this one and try this one. Right?
Find the force.
Find the repulse, the magnitude of force, the repulsive force. 8 nanometer coulomb, 40 nanocoulomb, 10 cm.
Nanometer means times 10 to the power -9, right?
Yep. You can calculate that if you want to. Right? I have to switch it off already. Okay. 8 and
yeah, okay, sure.
Or do your checkpoint.
Okay. Okay, sure. So 5 minutes break.
Yeah.
Okay.